Hi group. In this video, we're going to take a look at some of the data available. This video will focus on the taxi data. So what I have here is I multiplied my longitudinal acceleration by gravity. So now it's in feet per second squared. And I graphed it. And this is supposed to be the speeding up section. And this is the slowing down section. And we have this really interesting phenomenon here where it looks like this is probably where the aircraft kind of paused and then started speeding up to get out of the way. Okay, so a few things. First of all, I would probably kind of stop here at like, what is that? 43 seconds. So there is absolutely nothing. Oh, and I've already deleted times 0 and 0.2 because it was nonsense data. So I think one of the things I'm going to do with my slow taxi data is I'm going to go ahead and delete this ending data because it's not part of the slow taxi. And I'm not going to feel bad about it. We're just going to hit the delete button. Okay, so I'm going to go to 44 seconds and right click and delete. Okay, so now I have some data that's a little bit easier to look at because I lose that last bit of the data. And the next thing I notice, it's negative acceleration when the plane is speeding up. It's positive acceleration when this plane is slowing down. So we have the acceleration pointed out the tail right now. So I'm going to go ahead and change times 32.2 to times negative 32.2, and let's turn this guy around. So now it's speeding up and slowing down. So the next thing I observe, this is awfully close to 0, and that's supposed to be braking. This starts at 2, which doesn't make a whole lot of sense. So I'm going to suggest that we correct our acceleration by this smallest acceleration and subtract that. So that's about 1.5. Because it should really start at 0. They hit the go button just before the pilot started accelerating. So now I have some data that starts at 0. I have some maximum acceleration here. I have some braking acceleration. And now I can approximate the speed when, the maximum speed would happen here, right? And then how slow did the plane get before we stopped looking at the data? And so how do we do that, right? So my velocity is starts at 0. And then I'm going to look at the delta velocities, where I have acceleration times my time step gives me the change in velocity from step to step. And so I could graph my velocity in feet per second and see that according to this, so I'm starting at 0, I'm maxing out at about 90 feet per second, and I'm slowing down only to about 60 feet per second. So something still seems a little wrong here. I also see it's kind of parabolic, where the acceleration is linear, so that matches expectation. It's fairly linear, where the acceleration is steady. And then it's parabolic again as the acceleration is linear. So this all matches my understanding of the kinematics of the situation, okay? And then if I come over here to GPS airspeed with time, so last example here, I'm seeing the GPS airspeed max out at about 70 feet per second. So that's, and it slows down to about 20 feet per second. This seems a lot more reasonable than what I've got for the longitudinal acceleration. So it seems like maybe my longitudinal acceleration has a bias. We talked about this in I&M, where if you have a bias in the system, it's skewed one way or the other. So you know, I could play around with this a little bit and kind of experimentally see if I can make heads or tails of this. What happens now? You know, that makes more sense compared to the GPS. GPS data is not perfect, by the way. But so what I'm going to do, I'm not just going to pretend this is the data. I'm going to explain that I had to invert it with a negative sign because it was in the wrong direction. And I had to subtract a bias, which I identified here as -2. Maybe you identify a different bias. So in this example, I'm trying to explain how we analyze the data. Now, however you treat the slow taxi data, you should treat the fast taxi data exactly the same way. So if you identify a data bias of -2 or -3.5, doesn't really matter what, I want you to use exactly the same bias. Let's see. In your fast and slow taxi. So as I plot this, still makes sense, right? I have a nice constant acceleration. I have a nice constant braking force. So I want you to think about what that is and make sure you're using the same bias in both. It is unlikely that the same accelerometer has different bias. So that concludes this quick video. Questions absolutely welcome. Hopefully this helps those of you looking at slow and fast taxi data.